So in this video, we're going to look at a second formula, and this one is also going to be exponential. So you're going to read the problem and you're going to see a percentage. And so as soon as you see, 5% growth, 12% growth, 5% depreciation, anything that's a percentage, we're going to think exponential. But again, there's three different options for formulas. So as important as it is to know when you have exponential, we need to make sure that we're using the right formula at the right time. So the keyword we're going to focus on right now is continuous. So when I have continuously compounded interest, I can't use y equals ab to the t because that's specifically for things that happen just one time a year. I also can't use my compound interest formula because there's no number to use for n. When it was semi-annually, we could use an n value of 2, or maybe daily, we use an n value of 365. But you can't quantify something that happens all the time, something that is continuous. And so the letter E helps us capture that idea. And so without kind of going through the proof, the idea here is that we are going to use the formula y equals PE to the RT, which I like to just call PERT for short. And in addition to the word continuous, you could also be looking for the word relative growth, or it might say something like relative growth rate. Either one of those keywords should be kind of like sirens that go off in your head, because as soon as you see either one of those words, that tells you it absolutely has to be a PERT problem. And if you don't see those words, if you don't see the word continuous, if you don't see the word relative growth, then this is absolutely not a PERT problem. So it's pretty easy to know when to use PERT. P is still our principal, or what most of you like to call the initial value. E, as we talked about in class, is just 2.71828. It's just kind of like pi. It's an irrational number that we finally decided to use a letter for. So we're going to be plugging in for the P. We're going to use E in the calculator, and then we're going to be plugging in for R and T. And here again, because we see the letter R, there's no need to add in the 1, like we did with the AB to the T formula. We can actually use just a simple decimal as our rate. Okay, so let's try an example. So find the amount after 5 years if $1,000 is invested at a rate of 12% per year, compounded continuously. So I don't know if you want to circle it, highlight it, put a little cloud around it. When you see that word continuously, you know exactly what to do. That tells you stop, you're going to use PERT. So my $1,000 is going to be my initial amount. 12% would be the decimal 0.12, and my time is 5 years. So this is what my setup looks like. And in your calculator, I'll put that up really quick. When you type in your formula, you're going to hit the second button and natural log. And you can see right above the ln is the E. And what that's going to do for you is it's going to bring up the E raised to a power. If you have an older calculator, then it's going to look like this. Okay, so you'll notice in kind of the older calculator, we have 1,000 and then E raised to. And then very important here, and this really goes for the old and the new versions of the calculator, that the R and the T are part of your exponent. So if you were to drop the parentheses, you would not get the right answer. So in this particular case, I should get 1822 12, which I do. But I do want you to notice the difference if I type it in without the parentheses. Okay, so just for comparison, with parentheses, we get 1,822. And then if you do it without parentheses, you get something in the 5,000. So I just want to kind of just impress upon you early that parentheses absolutely matter. So if you want the 0.12 and the 5 to be in parentheses, then you absolutely have to put them grouped together so that the calculator knows that both of those are exponents. Otherwise, it's going to raise e to the 0.12 and then multiply that answer by 5, which is not what we want at all. So just be really careful when you're typing those in that your exponent has two things in it and therefore it needs to be grouped in parentheses. Okay, so on to our second example. If $3,000 is invested at 9% per year, Find the amount of the investment at the end of 5 years. Okay, so it may not be obvious at first, but again, I want you looking for key words. Find the word continuously, box it in, bubble it in, put some stars. And if you're looking at example 3, it doesn't exist. Like there absolutely is no word continuously. I also do not see the word compounded. So compounded annually, compounded monthly. So if neither one of your keywords are there, we are simply going to drop back to AB to the T. So don't get so excited that thinking you're always going to use the same formula, because we absolutely want to make sure we are looking for keywords, and if none of those keywords exist, then you go back to AB to the T. Now, you also have to be careful with AB to the T, because remember, since the letter B is not your rate, you have to add 100%. So 100% and 9% is 109%, which I converted to decimal, 1.09, raised to the fifth power, which is $4,615.87. So keywords are huge, because both number 2 and 3 have a percentage. One of them has a keyword, one of them doesn't. So you've got to make sure you're looking for keywords so that you're using the correct formula. Okay, just to look at a couple more examples. In number 4, we do see the word continuously again. Feel free to box it in, color it in, star it, so that it jumps out to you. So as soon as you see that word continuously, you should be setting up a Pert formula. Really, the only thing that's different about this one is that my population's decreasing. So when I change 4.3 to a decimal, that's going to be 0.043. And since I want my population to decrease, I'm actually just going to stick a negative in front of it. And this is kind of where we're at. So PE to the RT, and I don't think I mentioned it earlier, so I'll say it now. Notice that your PERT formula has an RT, and the compound interest formula in the other video was NT. That makes a huge difference in your final answer. So as you're memorizing your formulas, notice that those exponents are different. So I have my R, which is my rate, negative 0.043, and then my time, which is 6 years, and that gives me 41,720 people. And I know in science class you've probably talked a little bit about rounding. I'll kind of go over that really quickly. The idea here is we're actually going to round this up to 41,721. And if you remind me, we can talk about this more in class. But the premise here is, what's the best way to say it is, if I have 0.14 of a person, he's not dead yet. So when my population is decreasing, I'm actually going to still count this 0.14 as a whole person because he's not dead yet. It's kind of the easiest way to know to explain that. Now, if my population was increasing, then I actually would round this as 41,720 because this 0.14 hasn't quite added to my population yet. So based on if your population is going up or down, you do round slightly differently. And then finally, on your last example, pretty straightforward. You see the word relative rate of growth, which was one of the other keywords we talked about at the top. The only thing to be careful of here is that when you put this in your calculator and get a final answer, because 6.1 is billions, then you must interpret your final answer also as billions in order to make sure that you understand that problem correctly.